Sea level rise is happening and we're not going to reverse that. We need to start preparing and planning for the future, and that's part of how this research is most important or useful for other people. My name's Ken Rubin. I'm associated with the University of Hawaii. I'm in the Department of Geology and Geophysics, and we're out on RV Falkor, and we're studying the submarine geology in Hawaii. It turns out that when we melt ice on the ice sheets in the high latitudes on the planet, and we add water to the oceans, that the ocean level doesn't go up the same everywhere.
Yeah, the research that we're doing today absolutely helps us look into the future. So we're studying a past succession of ancient coral reefs that grew during a time of really rapid sea level rise.
And all of this helps us understand the effect of sea level rise on coral reef communities on the century timescale. We're using the remotely operated vehicle Sebastian to make visual observations of the seabed and to collect samples. And we're using both ship-mounted and an autonomous underwater vehicle system for sonar mapping of the seafloor.
The relatively shallow waters that we're in the moment, the ship is actually quite good at mapping. Some of the areas we've already mapped are around about 150 to 200 meters of water. In that depth, the ship can generally get about 0.7 of a meter resolution. The AUV, on the other hand, when it's down there mapping, can get about 30 centimeters.
When we send the autonomous underwater vehicle REMUS out on a mission, what we do is we come up with a plan for it to go map parts of the seafloor, either with its side-scan sonar or with its photographic camera. And we program that mission into the AUV's onboard computer and send it out. And it operates fully autonomously, running under its own inertial navigation to carry out the profile of that mission. What we usually program it to do is collect side-scan sonar data of the bottom in a back and forth pattern, where it maps a line and then moves over and maps a parallel line. When the AUV is done with this mission, it comes up to the surface and the ship goes out and retrieves it. We send out the small boat and tow it back toward the stern, where it's clipped on to the crane, and we lift it out of the water and bring it back into its cradle. Once we bring the REMUS back on board, we download all of the data and then run it through our shipboard computers to process all of its raw data files from the sonar.
It turns out that sea level doesn't change at the same rate or magnitude at different places around the globe. And there are various geological reasons for that, complicating factors that we feel are fairly minimal here in Hawaii. So by comparing a high-resolution record reconstructed from Hawaii with records that other people have collected in other places, collectively these will help us make predictions about local rates of sea level change around the globe in the future.